Hello everyone, it is Tuesday. It is time to walk a few of our review items. As you probably know, everything we now do is for .NET 10 because .NET 9 is pretty much almost done. I think the way I had it in the agenda was slightly different from what I have currently here. So we start with the string one here. Can anybody on the call talk to that one? Otherwise, I'm gonna make an attempt. Not everybody at once, please. So the question here is basically when you use the string create API, basically what we give you is a buffer to write into. And the question is now, should we encode the behavior where the buffer that you are getting is effectively, I think, one shorter than the null terminator? And so basically, is it okay if we codify that behavior so that callers can assume that the buffer you are actually getting is 1 byte longer? So when they pass it to a native API, for example, the native API can safely use span length +1.
What does it mean to codify it? Is that just the docs thing? Because
Yeah.
what you just said is the case for the current implementation.
Yes, that's basically that's what codify here means. Is basically that we guarantee that you can do that. So we maintain that behavior. We don't say it's undefined behavior.
I see.
Which now would mean we can't change the implementation.
I don't think we could anyway. The parameter that you pass in is what the length you want of the string to be, and our definition of string length is the length up to but not including the null terminator. And we always guarantee that a system.string, when passed through a pinvoke, has a null terminator. So this is just called.
I'm trying to imagine how we could do anything else in the implementation.
I mean, you could imagine that we give you a temporary buffer, right? That let's say you give us a length that is like 20, and we happen to have a buffer length 20 flowing around. We can't give you that one because we have to give you one length 21, right?
Oh, sorry. Is this that during, like, if during string.create you then pinvoke that span? That there's already a null terminator there?
Well, not that there is a null terminator there. More like the buffer that you have, the span that you are given, points to memory, and you can safely exceed the length by 1.
I mean, I think we'd be to read it, sure, but to write to it, I don't think we'd want to say that anyone could write to that last position because they'd be overriding strings null terminator.
Well, I think that's the problem in practice, right? So if you call to a pinvoke API that basically writes to that location, it will put a null terminator there.
No, not if it writes something beyond BC. If it wrote S to that location.
Yes, that
would be corrupting the string instance.
Yes, so we could say, once the call to the delegate completes, we can verify that the last location still contains the null character and blow up if it doesn't, right?
I mean, we could. It makes the API that much more expensive. I guess I'm trying. What is it that people is?
My understanding is just what I just said. Like you basically call the native API, and the native API happens to write to that memory location, but it will write a null terminator. So how do you do that now? So basically we're saying, well, people do that today, it works. Are we saying that it's guaranteed to continue to work?
All right, but I think I would like us to say that if that value gets written to, it needs to be a null terminator. Otherwise, you're corrupting.
Yes, no, that one I think is totally fine. I think the question is more like you shouldn't AV, right? Or you shouldn't start corrupting memory because you're writing basically in the location that is +1 the length, right?
Right, but you might start AVing elsewhere in the process if you wrote something other than null terminator. Because right now we don't.
Yes. Yeah,
we
the
don't
same way
validate.
We would say you have +1. We would also say that must be null terminator. If you write anything else, it's undefined behavior. I think that would be the. Yeah.
I think that's fine. The only thing this is, I mean, I can't think of any other implementation that we would possibly employ that would violate this and be as good as what we have today. It doesn't feel constraining in any way because right now we actually give you the strings buffer. Your example of we have some buffer lying around, we would actually be making things worse because we would have to like then we have that buffer and then copy into the strings buffer as well. We'd just be adding overhead.
Right. And like people are apparently already doing this, right? Which is so like we probably wouldn't want to break people even if we did have to go out of our way to support compatibility.
Because the only real question that I think would come up from if you p invoke within string.create is, do we guarantee that we've already written the null terminator to the place you're not supposed to look, and or do we overwrite it again right before create finishes? And those both feel like it's not yours, don't touch it, but that's obviously not what the person here wants. I mean, they won't AV if they write a 0. If they write anything other than a 0, they shouldn't. And if they're p invoking with what they should consider uninitialized memory to be read, they shouldn't, because they should treat it as uninitialized.
Have we docked behavior around the state of the span itself? Like, do we guarantee that we've zeroed it before we pass it into the delegate? I mean, in practice,
whether or not we docked it, do we? Yeah, okay.
I don't know either of those.
I would assume we would, because otherwise, I mean, technically you can have a null terminator before the end, right? It just means that if you pass it to a string API that does a normal string length, it might return a shorter length than what string.length would return to you. So you can't really corrupt the string in that way if the memory we give you is uninitialized. It just means if you write less, well, the resulting string might contain some data that you don't want.
Well, it's more a question of if you were making assumptions about, I think the person who wants to pass it to APIs that write, Jeremy was hypothesizing, what if you passed it to APIs that read? And if
well, it's called string.create for a reason, right?
Well, yeah, but if the whole thing wasn't zeroed, then that would lead to very strange behavior.
Yeah,
I would agree with that.
So it's implemented by calling fast allocate string in the CLR, and I don't know what that does.
With zeros.
Okay. I mean, I like things at 0, but I know we turned off a lot of zeroing things.
So. Yeah, I mean, pipe writers normally don't, but it's a higher level API that uses pooled memory.
But I'm pretty sure we still have while we tell people do not mutate strings, I'm pretty sure there were fast passes in some places that basically relied on that for performance. Like I think the strings constructor that takes a character and a length, I think it still checks to see if the character is 0, is null. In which case it doesn't fill because it knows it already was. And then folks that wanted to mutate were using that constructor to avoid any overhead and then filling it up themselves. It's neither here nor there. This seems fine.
All right, so then I guess we do that, and then we move on. All right, then the other one was this part.
Sorry, can you just, while you're there, can you just go back for a sec? We should probably just add a docs label to that, since it doesn't actually require any changes to the implementation, right?
That's true. Do we have a docs label for, what is it?
Documentation, I think.
Would we add a test case to make sure that like didn't row or something? I don't know.
Yeah, that's fair. I mean, it would be non-deterministic.
What would it do? Yeah, yeah, fair enough. It'd be hard to test that it broke. I think docs is fine. Unless we want to add like a comment to the source code where it's like you were saying earlier though, like how would you even break it?
I mean, if it's that we're guaranteeing that when it starts off, it's written requested length plus 1 0 value characters, then that's easy enough to test the initial state of the buffer.
Not really. When the test runs, that particular run might have all zeros there.
Yeah, but if the test ever fails, then like.
Right, but it doesn't guarantee it. It's hard to validate the absence of something.
Indeed.
All right, so then this one here.
Yeah, I can speak to that one. So the proposal is to change the enumeration that we have for trimming purposes. For trimming, we have dynamically accessed members types enumeration, and that's basically an enumeration that lets you tell trimming what members of a system type instance are you going to access dynamically. The way we originally designed it is to mimic binding flags. So if you say binding flags non-public and then use reflection API on something, then it will look at non-public members in the current type, but not in the base types. If you use binding flags public, it will look at publics, and that includes base types as well. So we often have situations where we need to access non-publics in base types. And whenever something like this happens, you cannot say that you would like to access public methods and non-public methods, or just non-public methods, because it doesn't include the non-publics that come from the bases. So to cover those right now, we have dynamically accessed members types.all that includes non-publics. But the problem with it is that it includes really everything from the type. So like all the members, all the nested types. It even goes to interfaces and lists all the members of the interfaces as reflected on. And this has, one thing is bad size implication. The other thing is that we run into a couple times with trimming as well, is not just about the size, but also in trimming, you can sometimes say, oh, this member is not safe to access using reflection. And whenever this kind of annotation includes one of those, then we generate a warning. So it's not good to use all, or like it's not good to use something that is more broad than what you actually need. And all is usually more broad than you actually need. So it has been causing us problems with both extra warnings and extra size. There is one issue at the bottom where we actually ran into it very recently, that like someone wanted to do something and it's like a 8% size regression, because marking all the like IEnumerable, iCollection, iDictionary interfaces as reflected on causes like really bad size problems. So this proposal is to add all properties, all events, all fields, like all of these things as a separate category, so that if you only want to access methods, we wouldn't also mark like all the like private nested types in all of the bases and all members of interfaces as reflected on.
Do we have a way to say every constructor that is public and in its basis? Is this implied by public or? So constructors are even special, because right now if you say public constructors, it only includes the constructor in the current class. It doesn't go into basis, because that's how Reflection API works. Right. So constructors is even different from like the others, because if you say public constructors, it's only for the class that you reflect on. So all constructors would mean constructors from the basis as well.
Actually, I had a few questions, but that was one of them. I understand, I think, what it means for things like methods and fields, but in what situation would someone care that constructors on base classes were being kept, including ones that weren't being used by derived constructors?
So for all constructors, I don't have a very strong motivation besides parity with the others I'm proposing here.
Just for
Is dynamically accessed only used for invocation, or is it also just for browsing metadata?
So it's also used for browsing metadata. So basically, with this annotation, you can annotate the storage location. So you can put it on a parameter, or you can put it on a field, or you can even put it on a generic parameter.
Right.
And then whenever we are analyzing for trimming and you read something from a location that is annotated like that, then we know, oh, it's safe to access members. What we do specially with these all things and the existing all annotation is that if you access the .base type property on such type, then we know that whatever base type returns has the same annotation as what the original value had. So if something is currently right now annotated as public methods, and then you access .base type, then like whatever type comes out of it is considered, it has all the public methods accessible. On the other hand, if it's annotated non-public methods and you access .base type, then we take it as like, oh, okay, this is unknown. We don't really know what members is it safe to access. So this is to cover situations where you usually have a while loop, like while base type is not null, then do something. With these new annotations, you would be able to say, it's safe to access privates. That's basically the proposal.
Two other related questions. One is, it seems like the new value is basically just saying the thing that's being asked for also apply to the base type or base types. Do we actually need different values for constructor versus method versus fields, or is this really just one value which when ORed into the respective thing means also traverse the hierarchy?
Yeah.
Like this is 0x4000, 0x8000, 0x10,000. Could there just be one value that meant, consider ancestors, or the opposite of declared only, basically?
Yeah.
The question is basically whether you would want to merge these with a finer granularity, because you can have some code path that is only accessing fields on the current instance, and then you have a different code path where you would do the recursion into the base. Whether we wanted to be able to express that I'm recursing only.
I think I wasn't being clear in my question. Right now, you have for all constructors, you have 0x4000. For all methods, you have 0x8000. For all fields, 0x10,000, etc. Could those all just be 0x4000? And just say that 0x4000 meant traverse the hierarchy and on its own, it would be meaningless. But when combined with public methods or non-public methods, it would mean something. When combined with public events or non-public events, it would mean something. You know what I mean?
Yes. That's what I was trying to explain.
Oh, okay. Like, then I'm not understanding.
Like you might have a code path in the app where you don't go into base classes, but you take a system type from some location and you look at fields, and you look at fields only in the current instance. And then you have some different code path somewhere else where you actually go into bases, but you are looking at methods. Yeah. The question is whether we want to be able to express in the annotations that the fields you don't want to keep recursively, but the methods you want to keep recursively.
Yeah, but I mean, because basically you already have these things here, right?
Yeah.
So
I'm not suggesting not having all methods, all fields, sir.
Yeah, it's just that this modifier here could be the same, right? It could be like replace this with ancestors, but then you have ancestors or public constructors or non-public constructors, and you have ancestors and public methods and non-public methods. You still have different values for each category, It's just that the mode that you have, which is basically traverse the hierarchy, is a single value. Does that make
But
sense?
how?
I think I heard
question is
the
how-
counter being you want ancestor constructors, but only non-ancestor fields.
Sure. Then you would have all constructors and public fields.
Yeah.
But you're setting this all in the same. You're ORing them all together. So,
No. That you would use all constructors in one place, and you would use public fields or non-public fields in another place.
But
So
don't
you
these go
query
in
twice.
in an
Is that the-
attribute? You say
What's that?
which. This all
Oh,
goes
I
in
see what you're
in an
saying.
attribute.
Oh, I see.
use the following things when you call
Yeah.
this function.
I see.
So they
I
all get
see.
ORed together of what will this function ever do.
Gotcha. Yeah.
I
that
see.
makes sense.
Okay.
So I think it's ancestor constructors, ancestor methods, ancestor fields.
Mm-hmm.
And then now you can say, I want all constructors and public methods.
Yeah.
And then now you don't get ancestor public methods.
I see. Okay. That's fair.
and-
But the ancestry is that today without this proposal, if I say public methods, that's declared only, or that's also on ancestors?
Public methods, it's from ancestors as well.
So-
Non-public
so-
is the difference.
Oh,
Okay.
Jesus. Okay.
So this new flag is really non-public inherited, basically.
Except for constructors, yes. So
Do we need-
constructors are that special one that they don't, like public constructors will not make public constructors within bases visible.
You were advocating for the fine grainedness here because you might want to do things like all public, non-public and inherited methods, but only a subset of that for fields. Do we need these new values to be named so that you could say, I want non-public inherited methods and but not public methods, for example?
I don't know if that would provide value.
Okay.
It might provide value for constructors, maybe.
Will
But
the
it
will the
can-
tool respect that? Like if someone just wrote hard-coded 0x8000, will it do what it would logically do? Like that would only keep non-public inherited methods?
So the way that the tool currently operates is mostly looking at the public constructors on public constructors, and we would probably not want to teach the tooling to about this value in many other places. Probably the only place that would deal with the 0x8000 would be the dot base type analysis. So the dot base type would look at this bit, and if the bit is set, then it would inherit whatever is there for like events in this case. But I don't think we would want more semantics for it.
But
It
that's one of
basically
my
just says-
question is, would you be if it looked at that bit to see what it said, would it also be validating that the public methods bit and the non-public methods bit was set? Well, because I'm otherwise if
Because-
someone could just specify 0x8000 and it would quote quote work.
Yes, for non-publics, I guess. So if you do like 0x8000 and non-public events, then I guess the tool would just accept it. For like the biggest difference would be for constructors, because then you can do 0x4000 public constructors or 0x4000 non-public constructors. I don't know if we need such granularity. We could have such granularity.
Okay. I don't have a strong opinion either way. It just feels strange to me to have everything be well defined except for these set of things which are sort of this hidden detail. But
I don't like that we're giving a bit a purpose but not naming it. So we should name it.
Yeah, so with the granularity you brought up earlier of being able to look recursively for one member type but not the other, like recursively for methods not fields, or I forget exactly which example you used. Was that a real example or was that a hypothetical? Sorry if I missed that.
Which one? Sorry.
Just like, so you know, Steve proposed that we have a single bit for like enable recursive lookups for whatever else is selected. And you said, well, maybe we need more granularity. Was that like an actual use case that we have where we want more granularity in this way?
I didn't think about it in details. We just have like, we have currently .all, and that's the non-granular one, and that one is really painful because it causes us like issues in the two categories, like the size and extra warnings. So it just felt like I want to be more granular because we had issues with the less granular one already, and maybe this is again it will make or break something else.
Because like obviously we could go more granular even yet, right? Like instead of adding 6 bits, we could add 12 and be like recursively look up public constructors, but not non-public constructors or something weird, right? Or if it doesn't make sense for constructors, something else. So like, you know, I was just wondering if there's a particular reason why we stopped where we did at the 6 bits.
So the extra bit would basically only allow us to go with constructors. So it wouldn't make a difference for methods because all methods and public methods and all methods and non-public methods, like for public methods, the all doesn't make a difference because public methods already includes publics from the basis because that's how reflection behaves. So the extra bit only makes sense for non-public methods. And that it's like that for fields, properties, events, nested types, I'm not sure. Constructors, there is definitely difference between like public constructors and go into bases and public constructors, and non-public constructors and go into bases on non-public constructors. So we could make this complicated for the constructor's sake, and maybe nested types, I'm not sure about those. For the methods, it doesn't make a big difference, I think. I guess eliminating public methods would help, yeah. Whether you want to say like all non-public methods, sure.
Yeah, I'm not sure. I was just wondering if there's like kind of a philosophy or like a rule that you were following. But yeah, the point you make about it not making sense to have a bit for the public ones when they're already recursive makes sense to me.
So what Jeremy said is he wants to have it named. Like you mean the constants that we are in right now?
So the hex 4000, hex 8000, hex etc. Like I can't think of an example off the top of my head where we've ever named a combination of bits where not all of the individual bits were named.
I mean, the question is why we care, because I mean, you can't really use them by themselves. And to me, the problem is public constructors is special, but public methods, public fields, public nested types, public properties, and public events pretty much imply the other thing if you use it by itself, which I think would be very confusing. You know what I'm saying?
I just think, but I think somebody looking at it, if they just look at the list of what things are in the enum, so they just IntelliSense and don't look at docs, they will think all methods is just public methods, pipe non-public methods, because there are no other things named methods. So all methods is clearly just a way of making those two existing bits appear shorter in your code. It's just an accelerator, except it's not. And that's where the confusion comes in.
Well, to me, that just implies maybe the name all methods isn't great, but it doesn't really imply that we would name the constant. But I mean, I honestly don't even know what shows up in IntelliSense. Does it actually show up like what it's right now, or is it just showing up as a literal? I think it does the latter, right? Because there's not a unique combination.
Well, IntelliSense would show that there's a thing called all methods and a thing called public methods and a thing called non-public methods.
No, I get that, but I'm saying I think for normal fit combinations, we actually render out the combinations in IntelliSense. I think when you actually look at the declaration, it actually shows all methods equal X or B or C. I just don't know what happens when you have an unnamed one in the middle, whether it actually shows it as a literal or whether it just gives up and says, hey, this is just a fixed value. But I mean, I don't know. Like the question is like, you know, I mean, to me, it just seems like you're trading problems, because if you, let's say we name it, let's say ancestors, right? And we say this is, you know, ancestors or public constructors or non-public constructors, right? Like, is that, can you now combine them? Can you say public constructors or ancestors? Yes, you can. Do we want to? Like, are all these combinations legal?
We'd have to come up with a reasonable name for it, but again, my concern is, I think an average person would think that all fields is the same as saying public fields and non-public fields.
Problem if the public ones already are basically already declared and inherited, how problematical would it be to say that the non-public ones are retconned to mean the same?
Might break code, right? Like
it's only increasing the amount of stuff that would be kept.
Yeah,
I see.
Yeah, so it's who wants non-public but doesn't want non-public ancestors.
I think I know where you're heading now, because now you can imagine another flag that basically excludes the
if it's even necessary. But yeah, we could. You leave the existing ones as public, non-public. Mm-hmm. And it means declared and all inherited. Mm-hmm. And then if we found a need for excluding inherited, we can do it in a consistent manner across both public and non-public, either having a single flag that is basically declared only, like on reflection.
Yep.
Or we could have one that was public declared only, non-public declared only, to split across them. But yeah,
I think I like that more, because then you end up in a world where the combinations are self-explanatory. You know which ones go with which.
Right. The downside would be if we believe that people that are already specifying non-public, if by really don't want inherited, and by automatically making it inherited, we're going to balloon their app size measurably. So I don't know the answer to that. I would hope the increase would be relatively small, but I don't actually know.
So if we want to change the meaning of non-public to also include the bases, that one would be a breaking change.
Why would it be breaking?
You can have something in the bases that is not friendly to be called by reflection. So for example, you can have a method that has a system type in the signature that has one of these annotations. The tooling needs to warn whenever you reflect them on that one, because if you are invoking dynamically, we don't know what is getting passed there. We didn't preserve all the members that are necessary.
I see. So you're saying, for example, if I had public properties or non-public properties and I changed that to all properties, that might start issuing new warnings.
Yes.
I guess
it's especially like for methods, because the method itself requires on reference code, for example, and it is somewhere in the basis. It's a non-public. It was never seen as a target of reflection, so kind of we never preserved it with that purpose.
Well, I admit part of my motivation here is I always forget that with reflection, non-public does not imply inherited, and it bites me repeatedly.
And it would be a breaking change, right? But it would be a compile time breaking change with a workaround, because we would add the ability to turn it off, right?
Yeah, but you can have the base type coming from one NuGet package, someone else is reflecting from a different NuGet package, and you might not be able to control where the warning shows up. It can show up on the app side. It doesn't have to show up in like wherever you are making the change.
Right. So like the person who would have to use the new bit to like turn off recursion might not see the warning until their customer like it starts enabling trimming or something.
Yeah, I would rather not change the semantic of the existing flags. They should stay as they are. The thing is, like, the non-public methods, that's why it matches binding flags, because that's how people are going to call it. So they'll just say non-public methods and then binding flags on public, and it works. It doesn't preserve too many things. It preserves exactly what is needed. Except we have these scenarios where people go into base types and then like have a while loop until base type is null. And that's the thing that we need to address. Right now, we don't have a good solution for it except for all, which is overly broad.
Right.
The other issue with all is that all also includes the nested types, and nested types are often things like, I don't know, various captures and state machines, and that becomes really problematic if you reflect on it. And then inside it, you are doing some reflection that needs to be analyzed. Like in trimming, we actually analyze the state machines so that you can use these data flow annotations as part of async or as part of like yield return. And that messes up things really badly if you actually go and reflect over the state machine, because you can change fields, do whatever you want.
I see.
Private reflection always lets you change fields to whatever you want. That's the good and the bad of private reflection.
Yeah, but it's problematic if you want to then statically analyze what it will do. So I'm not opposed to naming the 0x4000 something. It's just I have trouble coming up with good name for it.
I hate pushing like too hard against the product team about like not wanting to make a major breaking change, but like, you know, you make the point about library authors perhaps not being warned about the fact that their previous usage of non-public fields is now dynamically accessing or claiming to dynamically access way more than it did previously. But the scenario you bring up is like, okay, it might warn the library author. Well, it wouldn't warn the library author, it would warn the app author, right, when trimming. But all those warnings would be false positives, right? Like you could suppress it and like file an issue against the library.
Yes, so we don't have good mechanism to suppress warnings in the library, so you would have to suppress the whole category of warnings, which is not great.
I do like the cleanliness of like, you know, I know it's been this way for now 4 releases, but I do like the cleanliness of like the recursive nature being, you know, its own bit and not like tied into like whether you're using public or non-public. But yeah, if that's a no-go, I guess you should move on and consider things like naming. But it would make naming easier. just to point out.
So then I guess we want named flags, we just don't know the name.
Yep.
It should be some name that is not confusing, that someone would use it on its own, like that they would say recursive constructors and then they don't specify public or non-public.
Yeah, like I'm probably okay instead of, naming hex 8000 specifically, naming a combination of hex 8000 with non-public methods of ancestor non-public methods. And then we're like, well, obviously you are your own ancestor, so. But I don't like that all methods is the two other methods named bits plus a secret bit that you can't reason about when you look at, if you just look at what the enum members are. You have to look at what their values are to realize all methods is also some other special thing we don't talk about. And so that's really where I would prefer that we name the bit, but if we can't name the bit without naming the combination of that with non-public, then that's fine. But like we could call it include non-public ancestor methods. And it's like, well, that's now a really long bit name. So clearly you're just going to call all methods, but hey, we named the bit. But when you type member types dot meth, it's like, well, I got 4 things for you. Public methods, non-public methods, include non-public ancestor methods, and all methods. And you're like, all methods.
I have to say, I think I would prefer to just fix the naming for all constructors, all methods, all fields to something like all constructors and inherited, for example, or something like that.
Sure, you throw the word and in there and at least it says it does something more than just storing the existing bits.
Yeah, because the problem is like, I don't see, if you just look at the dynamically accessed member types right now, like all of those values are usable by themselves, and now we add one that is not usable by itself, which is odd. So I'd rather keep it simple and say, yeah, there's some secret bit in there that you can't express, but that's fine because you don't actually have to. I mean, all constructors with inherited or and inherited would probably be better.
All and does sound kind of funny to me. If you said all inherited constructors, I mean, I guess that would imply that non-inherited constructors aren't included. Yeah, I don't know.
I don't know if it helps this conversation right now as a precedent, but dynamically access members types dot all is defined as like all the bits are set. So there is a bunch of bits that don't have any meaning, but dynamically access members types dot all sets them.
That's the other issue I kind of have with all and in a name. It almost implies that it could be more all than all, which is clearly not the case.
Well, so instead of all and, to be all including.
Yeah.
All constructors including inherited. And you're like, what do you mean all constructors doesn't include inherited? I said all.
Exactly.
Like, well, welcome to issue 88512. Yeah, so Emma, that's why I had said I'm personally okay naming the combination of hex 8000 and non-public methods as, non-public ancestor methods, because that bit is usable on its own. Sorry, that enum value is usable on its own, because it's really only those two things together that have semantic meaning.
Oh, yeah, that one is.
And we assume.
And then all methods, if we leave the accelerator, would be public methods, pipe, non-public ancestor methods.
Yeah, I think that's the best proposal I've heard so far. If we want additional. members.
Yeah, I would just try to change it to a subset, but to a suffix. But yes, I would probably call them like non-public methods, including inherited or something.
Sure.
And then now they're all usable by themselves, and then the all methods say exactly what it does. Yeah, I think I like that. I think that's probably the. Yeah.
I guess, like, do we expect anyone would ever use that?
Well, now you have
Maybe.
symmetry. At least you can.
Yeah. Without referencing a magic number.
Yeah, I'm fine with adding something like that, non-public ancestor methods, fields, properties, events, and then for constructors we would probably want two, right? And nested types might be the same as constructors. I'm not sure. I don't remember how the reflection APIs work.
So you said non-public constructors is already recursive, unlike the other non-public ones. Is that it?
No, public constructors is not recursive like public methods. That's the difference.
So right now, if you want recursive public constructors, you have to use all. Is that one?
Yes.
Yeah.
You've done sort of a halfway thing here, I think, Immo.
What was the halfway thing?
We need to OR the things up top.
Yeah, the with non-public constructors with inherited needs to be that value pipe non-public constructors.
Apologies. Yes, obviously.
Or we can get rid of the with, and then all constructors becomes public constructors, non-public constructors, and non-public constructors inherited.
And I guess, like, based on what Michael was saying, we need something similar for public constructors with inherited. In maybe nested types. Oh, sorry.
If we name just the bit as constructors inherited, then the one bit could use for both public and non-public. But if constructors are different, then we might need to give them 2 bits. If we're going this approach of naming a combination of 2 bits. Actually, no, that's not true. We would call it public constructors with inherited is hex 4000 and public constructors, and non-public constructors with inherited. Though I guess it'd be weird because you say I want public constructors with inherited and non-public constructors, and then it would give you also the inherited non-public constructors.
Unless we want a 7th bit, but right. I mean, we could.
Well, again, it's the difference between naming the bit and naming the bit combinations.
But like, we can name the combination and add a 7th bit. Like, I mean, that's a different discussion. But yeah.
Sorry,
whether we think that's worthwhile.
No, what we are saying. Like, I thought the point of doing what I have on screen right now is so that we don't name a combination with an unnamed bit. So why would we have to OR anything into this?
Well, I think the point is you don't have to use the unnamed bit at all, because like it only makes sense in combination with the things we combine it with, and it doesn't make sense by itself.
Well, that's the thing, right? So like that was the very original proposal, and we said we don't like that.
Not exactly, because there's a useful thing-ish of like inherited non-public constructors, which you couldn't represent with this proposal without using the magic number yourself.
Sure. So then,
Because the like you called it here with inherited, so
Right.
something with inherited. That to me means you should already have ordered in the thing that was on the left side of the with. Because what you have on screen is you've just named the hex 4000 bit. So if I just said dynamically accessed member types, non-public constructors with inherited, I actually get nothing because I didn't say non-public constructors.
sure. So I mean,
So-
I can order that guy in, but then it looks exactly like the other proposal we originally had on screen.
The thing I was upset about was that all methods was something more than just the two other named method bits being ordered together.
I see, and the naming fixed that already for you, right?
So we can do the 2-bit combination of going with the with, or we can remove the withs and then make the accelerators specify public methods, non-public methods, and non-public methods with inherited.
So like that then.
Yeah. Then the thing with this that I think is wrong, if I understood where I understand that I'm wrong, is that constructors don't work the same as everything else, so this isn't right.
Yeah, constructors are inverted, right? Like the non-public ones are not inherited, right? Sorry, the public ones are not
The
inherited.
public ones.
Oh, so do we just need to
would
remove the non on that first?
No, but I think
bit,
you
or
have
is
to
it-
add the other one, right? Because the other one doesn't exist.
Yes.
Okay, so it's in everything else, public already includes with inherited, but constructors are only on the top level type.
And what about nested types? Is that
Okay.
worth the same as everything else?
Oy.
Yeah, so that I would have to dig out from the source code because I remember there was something weird about them. I don't know what.
All right.
Yeah, because I feel like it kind of matters, right? Because I mean, I actually think it makes sense, yeah, to use a new bit for public constructors versus non-public constructors. Like if we decide to make everything else granular, like why not that?
Right, because as presented right now, if you say public constructors with inherited pipe, non-public constructors, surprise, the non-public constructors are also inherited because the with inherited for constructors is the same bit.
Yeah, we should probably have a unique bit for that. I don't know which bit we can use though.
We have like we're running out, but I think we still have like 9 bits left or something. No, we have more than that.
It
We
looks
have
like
about half
it would
of them.
be the thing that we'll call hex 100,000.
Yeah.
I don't care, but yes, that works. So like this.
Fix all constructors.
I would say just note that we're using nearly 8 bits for like what's kind of a hypothetical, right? Like we thought 1 bit might be enough for our purposes, but you know, this is just more granularity is better.
And so I looked at the nested types and they do behave the same as constructors. So if you say public, it will not go into bases. So we would need 1 more bit for that. I don't know if we need the extra. Do we really need?
Well, if
So
it's
what-
7 versus 8 for consistency, well, I would argue it should be 1, but yeah.
Yeah, so if specifying all is including some kind of constructor, then we shouldn't add a thing called all constructors that misses some kind of constructor. Is my feeling. So either we name the concept that's missing, or we remove the all constructors accelerator, or something else. But if you're trying to get people off of all, then we shouldn't have an all something that is almost all something.
All right, so this is what I have right now. So basically, this model is the fact that constructors are nested types don't include the hierarchy for the public case. So you know every way to say it.
Does this model that for the nested types? Okay, we have public nested types with inherited. Where is that? I see it referenced below.
Very top.
All nested types is in the middle, and public nested types with inherited is the second edition.
Oh, I see. Yeah.
And so all nested type means public nested types of inherited and non-public nested types of inherited. And for the other ones, it's the public ones don't have to say with inherited because it's implied. So that seems to be the most consistent given the behavior that we have. Now we burn through a ton of bits, but not too bad.
I think it's fine. Like, I think you either kind of do what Steven suggests and change everything to be non-inherited by default and add the bit, or you do these 8 bits to be the most compatible and consistent.
Or we just add 1 bit, which is inherit everything, yo.
Yeah,
and not retcon what Steve was suggesting, which means
yeah. Well, the publics do what the publics do, and then we just add the bit of like inherit everything.
Yeah, that's true, and that wouldn't be breaking, right?
Michal, are you happy with that, or?
With which one? With what is on the screen, or what is being discussed?
Right now. That's the most granular, given the system, and also you can express all combinations now.
Yes, I'm happy. I'm a little bit worried that we are burning through so many bits, but it's just 2 extra bits compared to what I had. So
we can always add dynamically accessed member types too and have it along. So
yeah. I mean, the other thing is this is for 10. We're early in the release. You can
that's true,
claw these back. You have 9 months to do so.
Yeah, then sounds good.
All right, then let's do that. And I feel like we talked a lot about this one, but I guess it was worth it. Better be worth it.
One thing I actually kind of like about it is like the public with inherited things now being in this enum will be a reminder to people like me and Steve, like that this behavior exists with reflection / trimming APIs that like constructors don't inherit and the other ones do.
I would agree with that. Sweet. All right, so then back to the agenda. What was the other one I had? Oh yeah, another sad story. Fred, are you still with us?
I am, barely.
I'm so sorry.
Good morning.
It's okay. Yeah, so sad story indeed. Basically, we're trying to add a new feature in C#, 14.10, that is around first-class spans. So in general, this is a very positive improvement for the BCL because it means that you'll be able to define span-based extension methods and have them just work on arrays without users having to know or call to span or as span or whatever method they need to do in order to get them to be span or read-only span.
And also we can define them. We have a bunch where we've defined them for both span and read-only span, and the only reason we define it for span is because the ones for read-only span wouldn't otherwise show up as extensions on span, and this allows us to avoid doing that too.
Yep. So lots of goodness for the BCL. But there are 2 methods that use the same word in different meanings, and they are in very commonly imported namespaces. So you have system.memoryExtensions.reverse, which takes in a span and reverses it in place, and you have system.link.enumerable.reverse, which takes in an enumerable and returns a new enumerable that is the reverse of the previous enumerable. Today, that memory extensions API isn't applicable to arrays. In C#14, it will be applicable to arrays. And because we want people's code to generally just get faster, and people generally don't have the same method that means different things in commonly imported namespaces, the span-based version just wins. So you go from being able to say, for example, for each I in my enumerable.reverse, or my array.reverse, that just becomes completely different. It is now, in fact, reversing it in place and returning void. So in order to prevent that from happening, we want to introduce a new reverse in enumerable that takes in an array specifically. This beats both the existing enumerable based reverse and the span based reverse. Because it is an exact match for the array type, and that will just work nicely, as opposed to, and it will just work like that. We don't have to add anything else. It can just forward to the enumerable based reverse, and it's all just works out, and we don't have to worry about breaking changes in people's code for that when they're targeting .NET 10.
I mean, the alternative is they just have to do .as enumerable or .as span, right? If they want to MB.
Yes. Well, the workaround would be casting to enumerable.
That would make the Langver a breaking change, because as Fred said, if somebody has it as a for each reverse, that will now say this reverse is void. You can't for each void.
Correct.
Yes.
In theory, it's also like a potentially silent breaking change. If someone called array.reverse and just ignored the results of it, they would now reverse that array in place instead of returning a silent enumerable that's dropped. But that seems like a scenario that we don't need to care too much about.
Sorry, you mean if they call it enumerable.reverse, you mean?
Yes, if they called, well, if they have an array and they called array.reverse today and then ignored the results
using the extension method, right?
Yeah.
It does nothing.
Because there actually is an array.reverse method, I believe.
But it's
That's what I thought you were
I think it's a static method. You have to call array.reverse and then pass in the array.
Sorry,
right?
my array local.reverse.
Yeah. I mean, I'm sure somebody has that issue, but there's only so much you can do.
Yeah. So this is not, it's like, as I've put like 3 or 4 times in this proposal, this is not, oh, hey, let's go generally expand enumerable and add array-based methods. This is we have a specific breaking change, and we want to mitigate the breaking change. It is not, hey, let's go make first on on specifically arrays or just in general like that.
Out of
curiosity,
would the overall resolution attribute help us here? It probably doesn't, right? The priority one?
No, it doesn't. It doesn't, because it doesn't affect overloads within, it doesn't affect extension methods in different types. So if there was, if both of these types were in enumerable, if both of these extension methods were in enumerable, then we could use it. But because they're different types, that doesn't work.
It would also be weird because we'd have to solve this by saying we want to push down the span one.
Yeah.
And what we really want is maybe to say that we wanted to push up the enumerable one, but what we really want to do is just tell array don't take a breaking change.
Yeah, and that's what this proposal says.
Right. So anything already compiled is calling enumerable the enumerable extension method by the long name. So any IL is fine. There are no concerns. It's all compile time stuff. So it's new compiler, and we can reason about it easily. So what's proposed, aside from the fact that it won't compile because it should say this tsource array source, looks fine.
Yeah, sure.
But Fred, you said there were 2 methods, and this is one.
I'm not proposing 2 methods. There are 2 existing methods, and you change between which one you call now.
Sorry, did you mean one pair or two pairs?
One pairs. One
Okay.
pair of methods.
When you said there were two, I thought you were saying there were two pairs
Sorry.
of methods that had the same name
I
and
meant
different
two
functionality.
methods,
Okay.
both named reverse.
Okay. So this is the only break you've found so far in the new language feature.
Yes and no, but it's the only one in the BCL that we found.
Touche.
There was one in XUnit that we found, but actually Brad has already put the suggested fix for that into the 2.9.1 version.
Can we add a feature that disables this whole thing, or?
That's called using C#13.
No more overloads. Overloads were a mistake. No, I mean that's reasonable. Like if it's just this one thing, I think I'm cool with that. If we add like 20 more to make it work, then at some point there's something going on that's not good. But as a targeted fix, I think it's fine.
Yeah, and we've done we've compiled the BCL with this. We've compiled Roslyn. We've compiled VS. So we've gone around to a few several different repos with this change, and this is we've categorized where we found the breaks, and this is really the only one that we found in the BCL.
Cool. I mean, I know it's not a tiebreaker, but whatever. Close enough. So, anything else to say about it, or?
Nope.
Cool. Then, thanks for hanging out with us.
See you all later.
I'm afraid so. All right. Anybody can talk to this one here? Is Eric on the
Yeah,
call?
I can speak to that. Yeah.
Sweet.
Amazing. So in .NET 9, we shipped the new JSON Marshall type, and the design went through quite a few iterations. And at some point in between the iterations, we ended up dropping the API that exposes the raw span for property names. Currently, we're only exposing raw UDF8 values. And the customer came up with a request, so I think it makes sense to add it in .NET 10.
Seems fine.
So what does raw indicate here? Doesn't do any encoding if it's escaped?
It could be that the string is escaped. Yes.
I think I agree, but I'm just like reading the proposal. You mentioned that the properties don't include quotes. I assume the value, if it was a string, would include quotes, but that's useful because
if I recall correctly, the quotes themselves are trimmed, so you just get the contents.
Even for the value.
Yeah.
Anyway, that seems kind of like a PR design discussion anyway.
Yeah, well, because I think the quotes can only be the ASCII quote character, so there's no ambiguity. They're there by the language.
Yeah, I like removing them, I think. Just since there was dead air.
Do we need anything like this for the JSON DOM?
You mean the mutable one?
Yeah, the system text JSON.nodes namespace, JSON object.
No, it has a completely different representation. It's objects all the way. It's a tree, basically. There's no raw values to be considered as such.
Gotcha. So once you parse it, it's basically whatever encoding was in there is gone because it's already unescaped.
Yeah. Yeah. Well, with caveats, but yeah, basically what you said.
Yep. Then I guess I'm fine with that. Did we have a whole conversation about this raw stuff before? Wasn't that
Yeah,
one of those really contentious ones? And is this the resolution of that, or?
Yeah, the first method in the list got shipped in 9. This is proposing we ship the second one.
Gotcha.
Right, we'd have a lot more reservations about this had we not already shipped the first one. But at this point, the argument's over.
Whatever mistakes were to be made have already been made, so we might as well repeat them.
Pretty much.
That's called, there's a GAC. Let's get rid of the GAC. Let's bring the GAC back, but call it shared runtime.
It's not a GAC.
At least people tend not to drop random DLLs in the shared runtime folder. Hopefully.
Yeah, we made it hard. We didn't make it easy. So.
Well, and it just, there's decades of advice at this point, right? About like, just put the DLL in the GAC. That'll fix it.
All right.
Another JSON one. Okay, so this is again adding functionality to the JSON source generation options attribute. This one is an old feature, but I intentionally dropped it at the time because it needed some additional stuff like introducing an enum, and I wasn't convinced there would be demand. Well, now there is demand, and therefore now you have a proposal. So this is effectively bringing support for the reference handler feature in the source generator, but because the reference handler class itself, is a class, you can't actually specify it as an attribute. So we need a proxy enum that we can specify in the attribute. We've already done this with the naming policy type. This is basically just replicating this pattern. If you're interested, it's the JSON known enum policy, which I've linked in the proposal.
Oh God, this makes me so sad. Yeah, I guess. So what happens? So it's a closed hierarchy presumably, right? So nobody else can extend the reference handler.
No, it's not possible at this point, at least. With naming policy, it actually is, but in that case, like from the source generator's perspective, we say, tough luck. There's no way you can specify your own custom naming policy with the source generator. We just deal with the known ones.
So are we ever going to fix it? Does it mean we have another thing that we have to expose somehow, or is that something we think is permanently off the?
I don't think so. Honestly, I don't think so.
How do we solve this in other places? Like we call into the other thing, we call into the abstraction then, or how does it work normally? So,
assuming we had exposed the reference handlers as actual nominal types, public types that you could reference with a type of, it would be possible to have a pattern where you specify the type as a parameter, and we do that for the converters option. But because in this case the implementations are private, we can't actually do that. We could have done that, but it would involve exposing a ton load more API, and I really don't want to. I don't see a world where we make reference handlers like fully user modifiable. That would have been, I think, impossible / hell to implement.
Do you remember why we did it the way we did it then before, where we kind of have a hierarchy that you can extend?
I wasn't around when it was implemented, so I don't know.
Gotcha.
But
See,
basically,
I'm fine with that. I just don't like API patterns where we know we have a limitation. If we ever have to do it, we have to add a whole bunch of new APIs because you're already in this business of duplicating API surface here.
Yeah.
So if you think it's permanently off, then I think
I
it's
think it's-
fine. If we just kick the
I think
can
it's
down
off the
road
table,
and do it in
like-
2 years from now, then
the problem is that there are currently two implementations of the reference handler class. There's preserve and there's ignore cycles.
yeah.
Like these are fundamentally different things. Like
Right.
there's no unifying abstraction as such. Like it's just the placeholder that defines like two very different things, and the class defines completely disjoint methods for driving one or the other. I don't think that there's some sort of unified abstraction that we could be exposing to users for them to overload in this case.
I'm very happy we recorded this so I can play it back to you. But like it's no, I mean like it's fine. It's fine.
Yeah, I mean, if we exposed custom reference handling via custom types, then I think the extension would be you add public type custom reference handler, and you just have to leave reference handler set as unspecified.
Yeah.
In the property decal, you included the JSON prefix, and in the type decal, you have a comment saying you left it out. I assume you wanted to leave it out.
Yeah, because the type, unfortunately, isn't called JSON reference handler, and as such, it kind of goes against the, yeah.
I'm really saying they should be correct and match, and just making sure that
Yeah.
you didn't add the JSON having changed your mind and trying to put it back. So.
No.
And what's like what do we call it? Unspecified and not none?
Again, it's following convention from JSON known enum policy.
I see.
But unspecified means none, right?
Yeah.
Yeah. Well.
To pop some information back on the like the first thing we talked about today, the CLR that SharpLab uses at least does pre-zero the memory as far as I can tell, and does not care if you overwrite the null terminator. But I'm not going to let a program run long enough to find out what happens when that null terminator is missing. I stretched the span, overwrite the null terminator, it didn't put it back. So. Woohoo.
Do we have other APIs that are not unsafe that let you override the null terminator?
Well, this one doesn't let you. You'd have to use unsafe code to do so.
Yeah, I had to write a stretch for span that turns it to a pointer and then makes a new span with the same pointer and a length increased by 1.
Okay.
So you'd have to do that or p-invoke and have the other side not respect your size limitation.
I mean, we could install a watchdog service that automatically puts it back, right?
I mean, if we cared, we could make string.create after it invokes your callback. It could splat the null terminator back, but I don't think we care. It's you shot yourself in the foot. So.
No, I mean the whole point of the issue was to just guarantee you don't AV when you access that location, right? But like, I think it's fine to say you better put a null terminator there. If you don't, then you know.
Well, it's we put one there for you.
Yeah.
You better leave it there.
Yeah, you can write to it as long as you write a 0. Yeah, I think that should be the contract. You get to write a 0 there, or not, but you don't get to do anything else with it.
So I know we just approved this, and maybe you answered this already slightly, but like, I know internally we have something similar called like reference handling strategy. we like known reference handler and reference handler more than just like reference handling strategy. Because it implies that there's like support for an unknown reference handler, which as of now there isn't, and we don't plan on it. We could even keep the same names.
My
For the-
understanding, maybe
the
I'm
items.
wrong, but it was more about the naming convention that we had in the.
Got it. Except for that
in-
starts with Jason. Should this one then start with Jason? Jason, known reference handler.
Well, that's the thing, right? Like you have to pick the thing you want to be consistent with. The existing reference handler doesn't have the JSON prefix. So it's kind of like, yeah.
It doesn't have known either though. Like it's a prefix to known.
Yeah, my understanding was that the known one came from the other one we put there. Hold on, I now need to find the. System.
I have a link to it in the proposal.
Yeah, we already have JSON known naming policy, JSON unknown. Right, so I guess that would be.
Well,
the
if that
same.
one supports unknown, that could be our explanation for why we deviated. Because this one doesn't. But
I mean, the JSON known naming policy is basically saying, yeah, it's an open-ended thing. However, we only support these ones. So tough luck. And that's the same pattern here. Now, of course, you can say, well, then one starts with JSON, one starts without JSON, but that's kind of like, oh, we took the base name and we slapped known in front of it, right?
or in the
Yep.
middle of it.
In between of it, yeah, whatever. But you get the idea, right? I think it's. I mean, I don't know. Like, I mean, I'm partial to either one of those. I think the key point is the whole concept of known versus unknown is basically to say, yeah, here's an extension point. However, the source generator only special cases these 5, so that's what we ship. And for everything else, you're out of luck. And then whether it's JSON prefixed or not, well, unfortunately, we messed that one up back in the day.
Yeah, no, I'm fine with it. As long as we're all happy.
Well, I'm not happy, but
No, I mean it's not yeah. It's pretty good. I think the names are fine.
I mean, the biggest problem with system text.json is our piecemeal evolution of it. We have done a ton of feature work in it, and in many cases we have pushed the envelope of what we had in the framework, right? We moved to source generation, we had like fast APIs, and that unfortunately in many cases has bitten us, where we later on realized the API shape we had before doesn't quite work for certain scenarios. So it's just it's just yet another of those examples.
Yeah.
If we know everything we know now, we would go back and redesign it, and we would probably get a much less API surface. But
If only we had Simber, we'd rewrite it.
You know what though? Like as a consumer of libraries, like we would love it. But as a consumer of libraries, being like, hey, every year or whenever we decide to bump the major version, like, get ready for some breaking changes, isn't all that appealing. But I hear you.
well, I mean,
Yeah,
I just killed binary format. I'm happy to do this again for system text.json.
Right,
sure
it's like-
as well.
I mean, we kind of do Semver to an extent. Like the limited breaking changes we allow, we try to do on major releases.
I mean,
Yeah.
to be fair, this library has reached a point where, like, the design is so much informed by not introducing any breaking changes that it becomes difficult to use because of that reason. Like, it seems to start to buckle at this point, especially if you're using it in source generators, for example. If you're trying to write something that works with AOT.
I mean, this is one of those areas where it might be worthwhile to just entertain the idea and see, like, is this new thing actually worth the, is the new thing really that much cleaner and better, right? And see whether that's the case or not. I think in practice, the nice thing with serializers is that they are not really things you have a lot of API surface usually with, because they're usually at the leaves. I mean, the biggest problem is the attributes probably that you spread throughout the code, right? So, but as long as we don't make drastic changes there, source compat probably goes pretty far. So I don't know. I'm not at the point yet.
Clearly, it's time for system text JSON 2, the third JSON library.
Yeah, gotta follow our naming guidelines. If it's not sufficiently different, just put a 2 at the end of it.
I mean, isn't it Rich Hickey that recommended that you just put a v2 in the namespace and then copy paste and change it?
This is how we got COM.
Yeah.
X509 certificate 2.
I am well aware.
It's not version 2 of certificates, it's green bits and red bits.
No, the real pattern is Microsoft text.json.
Exactly. I mean, it's funny because it's true. All right.
All right, guys. I'm calling it a day. We have reviewed everything, and then I see you guys at some point again when you want to ship more stuff. Yeah, GUID v7. Yeah, thank you.
Yeah, maybe RJSON.
RJSON?
RJSON. Yeah.
Just Arson.
I like it. Yes. Ship it. All right.
All right.
Bye-bye.
Bye-bye.